Dear students, last class we saw extra formulas as well as extra concepts, and therefore we will now practice some questions, past asked questions based on such extra formulas as well as extra concepts. Let's take the first one as per our usual procedure. What I want you to do is now look at the question, pause the video if you want, and then practice the question by yourself, and then afterwards resume the video and then have a look at my solution, and then compare what you have done with what I am saying. Now, okay, so now that being the case, let's take now question number 42. The horizontal range and the maximum height of a projectile are equal. The angle of projection of the projectile is. So then, as what I have been saying, you just after you read the question, you just note down mentally what are the data which is given. Now in this case, what data which is given is R, H, and then what is asked for is theta. Then the next job you have to do is to now think out what from your memory what is the formula which is linking these three quantities. What are the quantities? R is give R, H, and then theta. Then which is the formula which is linking all these three quantities? Just take it out from your memory. Now we know that H equal to R by 4 tan theta is the formula. Now it is given now H and R are same. That means they cancel out. That means this 4 goes here. Therefore tan theta equal to 4. What they are asking is theta. You must answer as tan inverse of 4. Option B. Okay, let's go to the next question. A projectile is fired at an angle 45 degrees. Therefore theta equal to 45 degrees given with the horizontal. Then the elevation angle of the projectile at the highest point as seen from the point of projection is. Now imagine the concept. What is the concept? What is the figure which is given is like this. This is a projectile, and then elevation angle at the highest point. Highest point is this. The elevation angle means this is alpha. Elevation angle is alpha, and then the projection angle is theta equal to this projection angle theta equal to 45 degrees is given. Therefore now at the highest point, we know this is a concept about, remember this concept, tan alpha at any point divided by tan theta. That is, alpha is the elevation angle when the projectile is at any point P. Now in this particular case of problem, they are given the not any point, that is at the highest point. Therefore now this the formula is, we know, suppose this is now x, then the whole this thing is range is r, then this is r minus x. Now in this particular case, r minus x is r by 2. Why? Because this is now the highest point. This is r by 2. Therefore this must be equal to, as per the formula. What is the formula? R minus x by r. Now here we have to put x is equal to r by 2. Therefore you put this is now half. Therefore tan alpha by tan theta equal to half. What is tan theta? Tan 45 degrees. This is equal to 1. Therefore tan alpha is equal to half is what you arrive at. Therefore you must take the answer B. Then go to the next question. A bullet is fired from a gun with a speed of 1000 meters per second in order to hit a target 100 meters away. Okay, just draw the figure. This is ground. The bullet is fired. This is U equals 1000. And then this is a projectile which is reaching 100 meters. It's a range. At what height above the target should the gun be aimed? That means now above the target, that means what they are asking, this is now theta. Therefore now this extend it. The question which is asked is, what is this height? What height above the target that should be? Okay, therefore now what is the formula? What is given? So the question asked is, what is the height here? Right now, this looks very simple because this is a right angle triangle. This side is 100 and then this angle is theta. What is asked is opposite side. Therefore now the answer should be equal to 100 times tan theta. Only thing is now theta is not given. But then how to take out the theta, because what is given is u is given 1000 and then the range is given 100. Therefore now we can think about a formula is range equal to u squared sine 2 theta by g. Therefore now range is given as 100 and then u squared will be 1000 squared will be 10 power 6 sine 2 theta unknown divided by g 10. Therefore now sine 2 theta comes to 10 power minus 3, which is very low. Therefore now we can take now sine 2 theta equal to 2 theta itself. 2 theta is equal to 10 power minus 3. 10 power minus 3 means 1 centimeter. Therefore theta must be equal to 0.5 centimeter. Right. Next question is, therefore now theta is given. Theta is known now. Then what is asked for is 100 tan theta. Therefore 100 tan theta is now because theta is small, tan theta is nothing but theta. 100 theta. 100 into 0.5 centimeter will be equal to how much? 50 centimeter. Check there is something is wrong because it is given 5. Let's now recheck what we have done. 100 range equal to u is given as 1000 meters per second, therefore 10 power 6 u squared. Sine 2 theta is fine. Therefore this is now and then divide by 10. 10 is g. Therefore this is 1000. Therefore 10 power minus 3 is correct. Okay. 10 power minus 3 is not 1 centimeter, it is 0.1 centimeter. I am sorry. Therefore, this becomes 0.05 centimeter, the answer becomes 5 centimeter. Okay, so 5 centimeter is the answer. Understood? Next question. A projectile is fired from the surface of Earth with a velocity of 5 meters per second at an angle theta. U equals 5, theta unknown. Another projectile fired from another planet, and of course now this is g, whereas another g equal to 10, let us say. Then another projectile fired from another planet with a velocity of 3 meters, u dash equal to 3, and at the same angle, same theta, follows a trajectory which is identical with the trajectory of the projectile. That means now we are talking about, we need to now talk about the projectile path formula, trajectory formula. Y equals x tan theta minus half g x squared by u squared cos squared theta is a path formula, path equation, trajectory equation. Now it is given, now the Earth g is g, whereas planet g is g dash, some other planet is now g dash, whereas now, and therefore now it is now same equation is being followed, therefore y same, x same, and then theta also is now given as same for both cases, whereas now g is different and then x same of course, and 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 then u is different, therefore theta is same. That means now g by u squared is constant for both the planets, but is both for earth as well as this. Now in this case, now therefore now g must be proportional to u squared. That is proportional to, now they want to know what is the gravity, or what is acceleration to gravity on this thing is. Now g into this is 3 squared divided by 5 squared, which is equal to 9 by 25 of g. G 10. Therefore, let us take it as 0.4, 3.6. It means to be somewhere about 3.5. Correct? Understood how we have done? We have taken, because the trajectory path is the same, that means equation y equal to x tan theta, that particular equation has to be same for both. Which means only thing which are different is, because theta also is given to be same, is that u is different and therefore g is different. Therefore, from the formula we find that the g is proportional to u squared, because g by u squared must be same, which means now u1 is given as 5, u2 is given as 3. Therefore, g dash must be equal to, in this case, 9.8 into 9 by 25, or roughly 3.6. 3.5 is the answer. Understood? Then go to the next question. A particle of mass m is projected with a velocity v, making an angle 45 degrees with the horizontal. When the particle lands at the level ground, the magnitude of change in momentum will be. This is the standard concept. What we have said, standard concept, what we said is, initial velocity is u, then the final velocity when it lands also is u, but then the vector being direction like this, direction changes like this. Therefore, now the change in momentum. Now, what is the momentum? Initially is mu. This also is mu, but then at this angle theta remains same. Theta remains same. Now, theta is given as 45 degrees, right? Therefore, then what is the change in momentum will be? Change in momentum is like this. Now, final vector mu minus the initial vector. Initial vector is like this, minus means like this, opposite. And the angle is, this is 45, this is 45, therefore 90 degrees. Therefore, then what should be the answer? This is now the change in momentum. This plus this is this. What they are asking is, what is the change in momentum? Is equal to, and therefore this now being 90 degrees, this should be equal to root 2 mu must be the answer. In this case, now u is equal to v, therefore tick this. Go to the next question. A particle is projected at an angle 30 degrees from the horizontal with a speed of 60 meters per second. U equal to 60, theta equal to 30. The height traversed by the particle in the first second is h0, and the height traversed in the last second before it reaches the maximum height is h1. The ratio of h0 is to h1 is. Now there is no direct formula for this. This is a concept which you will have to work out how it is. Now this is now given, u is given, u is equal to 60 and the angle theta is given. Then the height is this is not total height, and then what is given is height traveled. Now this much in the first second is h0, and then the last second before reaching the top, this height is h1. Whereas this takes 1 second, this takes 1 second from the bottom. Therefore, what is asked for is h0 by h1. first of all, therefore now we should know, now this is 1 second, this also is 1 second. First of all, we should now work out from here what is that time to take, time it has taken to reach the top. That means t by 2. Because time of flight is t min, then the time for 1/2, that is for going up alone, is t by 2. Going up time will be same as coming down time, therefore each is equal to t by 2. First, let's now calculate the time t by 2. How? Because u is given, theta is given. Therefore, time of flight is 2u sin theta by g. In this case, now sin theta is half. Therefore, 2u sin theta is u by g is now 6 seconds. Therefore, the total time t by 2 to go up is 3 seconds. Therefore, out of which now the first second is here, the last second is here, which means what is now the ratio of the height in this. Therefore, we should now take out. Now look at it from the top. Now this is equal to half g into 1 squared. And then look at it from the third second. This is half g into 3 squared. Therefore, then this is half g into 3 squared minus. No. Already you know the well-known result, which is if a particle is having constant acceleration, then the ratio of the distance traveled during the first second is to the second second is to the third second is in the ratio of 1:3:5. Therefore, now in this case, therefore we should now take that this is 1 means this is 5. The ratio is 1:5. Therefore, h0 by h1 is 0.2. Understood? Read the next question. Two projectiles are fired with the same initial speed from same point on ground at angles 45 minus alpha and 45 plus alpha respectively with the horizontal direction. So now this actually says 45 minus alpha, 45 plus alpha means it's a well-known concept, which is that the range will be same because u also is same. That means range will be same. And then they are asking what is the ratio of the maximum heights attained. That is a typical h1 by h2. Remember the concept what we said, the h1 by h2 is proportional to sine squared theta by cos squared theta, correct? Why? Because now sine, that is 1 is theta, other is 90 minus theta, means this is now what is now the theta in this case is 45 minus alpha. Therefore, what they want is nothing but tan squared 45 minus alpha is the ratio. So, okay. Okay, therefore, now look at the solution. Understand. Therefore, what is asked for is tan squared 45 minus alpha, which is equal to tan 45 minus alpha ka whole squared, which is equal to tan 45 minus alpha can be expanded as 1 minus tan alpha by 1 plus tan alpha times whole square, which is equal to this can be simplified as sin alpha minus cos alpha by sin alpha plus cos alpha whole squared. This can be simplified as 1 minus sin 2 alpha by 1 plus sin 2 alpha. Therefore, that is the answer. Option 2. Then read the next question. A projectile is fired at 30 degrees to the ground is observed to be the same height at time 3 seconds and 5 seconds after projection during its flight. This is the ground, this is projected, this goes like this. Now at the same height it is found to be after this is now at time t equal to 3. This is the point which reaches t is equal to 5. which means exactly at t equal to 4 it has reached the top position because half the time and half the time. Okay, now 3 and 5 are at the same height it is given, which means now t equal to 4 it reaches the topmost point. That means now time of flight equal to 8. Let us see what they are asking. The speed of projection of the projectile is, now the angle theta is given as 30 degrees. Therefore, now time of flight is 8, and then the theta is 30. What they are asking is u. Therefore, now which is the formula which is linking time of flight u and theta is the first formula. Time is equal to 2u sine theta by 2u sine 30 is half by g is 10, 80. Therefore, u is equal to 80. Understood? Okay. Then go to the next question. Projectile is projected at 30 degrees from the horizontal with the initial velocity of 40. U equal to 40 given. Theta equal to 30 given. Then the velocity of projectile at t equal to 2 seconds from the start will be t equal to 2, velocity equal to how much? Fine. Therefore, now it is from the fundamental concept. T equal to 2 at t equal to 2, the velocity y component will be equal to initial velocity 40 sine 30 minus g into 2. Correct? No, the u sine theta minus gt. This must be equal to 20 minus 20 equal to 0. That means now the vertical component becomes 0. Obviously, that means at t equal to 2 is the half the time of flight that reaches topmost position. Obvious, because u equal to 40 means u sine theta is 20. Therefore, now u sine theta becomes 0 at t equal to 2 is obvious. Therefore, what they are asking is what is the velocity. Therefore, now at the topmost position, velocity is only u cos theta. The u cos theta is 40 into root 3 by 2 equal to 20 root 3 is the answer. Okay, simple question. Next question. Angle of projection. For a projectile to have the same horizontal range and the maximum height. So now this is horizontal range as well as maximum height and angle. What is the formula which is linking? The formula is h equal to r by 4 tan theta. Now it is said that it got the same r and h. Therefore this cancels each other. Tan theta equal to 4. I think it's the very first question which we solved. It is repeated. Then the next question. A body of mass m thrown horizontally with a velocity v from the top of the tower. Therefore, this must be horizontal projection. That is from the top of the tower, ground. This is now body of mass m thrown top of the tower of height h. This is given as h. Reaches the ground at a distance of 100. This is now projected. We do not know what is the u. It reaches at a distance of 100 meters. Range on the horizontal is 100 from the foot of the tower. A body of mass 2m thrown at a velocity of v by 2. This is actually is v is given, and then if it is v by 2 from the top of the tower of height 4h. Therefore, that means when it is 4h, and then from a v by 2, this reaches a height of distance of how much? Okay. Therefore, now what is the formula is one thing, whereas the fundamental is what is now the time here is root of 2h by g, whereas now the time here is root of 2 into 4h, that means it is actually 2 times, because root of 4, 2 times t. And then what is now the range, therefore 100 equal to initial velocity into time, whereas in this case now this is r dash. R dash is what they are asking. R dash equal to now t dash into what velocity is v by 2, which is equal to 2t into v by 2 equal to t into v, which is now same as this. Therefore answer should be same, 100. 100 should be the answer. Understood? Go to the next one. A child stands at the edge of the cliff 10 meters above the ground. This is now a height 10 meters above the ground. Throws a stone horizontally with the initial speed 5. Neglecting air resistance, the speed with which the stone hits the ground will be. This is the V formula for a horizontal projectile. This is V equal to how much is asked. So then we know from the formula. Otherwise also you can work it out from the energy conservation or from the formulas, kinematics formulas. Vertical component will be equal to 2gh. In this case 20 is equal to 200 is equal to vertical component square. Therefore this must be square root of 200 or 10 root 2 is a vertical component. Horizontal component remains the same as initial, which is equal to 5. Therefore what is now the V is equal to square root of 5 square 25 plus 200, 225, which is nothing but 15. Okay, this also can be remembered as a formula what I have given you for horizontal component when it reaches the ground is what I said as the square root of initial velocity u square plus 2gh. So the formulas can be written because u squared is now 25, 2gh is 200. It comes same thing. Either you can just remember the formula and directly use it. We don't remember the formula because normally what happens only the ground to ground projectile formula you will be remembering it. Horizontal projectile being very simple, you can work it out on the spot also. Next question. Read this question. A projectile is projected with a velocity of 25 meters per second at an angle theta with the horizontal. U is given as 25, theta is given as theta only. After small t seconds, its inclination with horizontal becomes 0. What is meant by inclination with horizontal becomes 0 means it is at the topmost point. Therefore, at that time only, then it is velocity is parallel to the horizontal only. That means now small t is equal to capital T by 2 because time of flight is capital T. Therefore, now time of flight therefore is twice t. Okay, that is given. Then R represents the range. If R represents the range, then the R equal to R. Then what is asked is what is the theta value. Therefore now U we should now take it as given, and then time of flight is given and R is given. What is theta? Therefore then what is the formula linking? What is the formula linking U, T and R, and of course theta we have to find it out. What is the formula linking? Obviously this is a very fundamental formula, which is range is given by U cos theta into time of flight. Therefore now in this case now cos theta is unknown, whereas U is 25, and then T we should put it as 2t. Therefore cos theta equal to R by 50t, or theta is cos inverse of R by 50t. Let's go to the next question. In a spring gun having spring constant 100 Newton per meter, a small ball B of mass 100 grams is put in its barrel as shown in the figure by compressing the spring through 0.05 meter. That means now the initial energy is the spring potential energy. That is half kx squared is nothing but half into what is k value is 100, and then x is given as 5 into 10 power minus 2 x squared. This is the initial energy total. Now there should be a box placed at a distance d from the ground such that the ball falls into it. This is nothing but a horizontal projectile problem. It's like this, that is from a height. What is if the ball leaves the gun horizontally at a height of 2 meters? That means now this horizontal projectile, this height is 2 meters and is leaving with a velocity of u. Then the question asked is, then a box placed at a distance d, it should fall into this distance. Horizontal range is given as d. It should fall into it. The ball leaves the ground horizontally. The value of d is d equal to how much? What is the range is given how much? Now we have to now see that the spring potential energy is getting converted into the kinetic energy for the mass. What is the mass is also given, I suppose, equal to 0.1 kg, 100 grams is given. Therefore, this must be equated with half m into u squared. What is m is 0.1. Therefore, half into 0.1 into u squared. Therefore, this must be cancelled off, and then 0.1 becomes, this is 1000, this becomes 1000. When this 0.1 goes there, this is u squared, this 10 power minus 4, this fellow is 10 power minus 5 squared is 25 in 10 power minus 4, so it is now 2.5, u squared equal to 2.5. Therefore, what is now the 2 meters height? Therefore, what is now the time of fall? 2h by g, which is equal to 4 by 10. Root 4 by 10 is 2 by root 10 is equal to time of height. Therefore, what we want is t into u is the range d. D is given by t into horizontal velocity u. Root of 2.5 into 2 by root 10 is the answer. Okay, this must be equal to the root of 4 equal to 2 equal to 1 meter. It comes to. Okay, right. Go to the next question. Water is filled up to a height of 12 meter in a tank having vertical side walls. A hole is made with one of the walls at a depth h below the water level. This is water. This is the water level up to a height 12 meters in a tanks having side wall. A hole is made in one of the wall at a depth h. Then the value of h for which the emerging stream of water strikes the ground at the maximum range. This is already a well-known result. H should be half the total height h. This is h means h should be h by 2. If h should be equal to 6 meters is a well-known result. Why? If you want to derive this, this is actually part of your hydrostatics, which is there. Which what happens is, now what is the velocity which it is coming? U is equal to root of 2g into unknown h. From this is a flux velocity, we know. Now you want, therefore this now horizontal, therefore this becomes h minus h. Suppose now h is the total height of the water, h minus h. I am now trying to derive you that well-known result in the hydrostatics chapter. So I am just now trying to derive it once more for you. In case you are not aware of this, then I wanted you to understand how to derive that well-known result of h. Small h is half the total height for a maximum range on the ground. Okay, now let's now take this. This is a flux velocity u. Therefore, now we want what is now the time of fall from the for the horizontal projectile, root of 2 into h minus h from the ground divided by g is the time of fall. Therefore, what is now the range r on the ground equal to u into t. Therefore, now what we are now doing we are now doing 2g into h, 2, therefore 2 comes outside, therefore it becomes 4, g gets cancelled, 4h into h minus h should be maximum, because you are looking for maximum range on the ground. If this maximum means, then root of h minus h maximum means, then you want this particular, this must be maximum. Maximize this. Therefore, you now differentiate it and then equate it to 0. Therefore, now it is differentiate with reference to h, 1 into h minus h plus h is taken common into minus 1 equal to 0. Okay. Therefore, this becomes h minus 2h equal to 0. This gives you h is half the total height. Understood how it is got from the, this actually, as I said, is a well-known result. Then all you people must know this already. That is, when you make an orifice at half the total height of water from the top, then what happens? Then the efflux stream reaches the maximum distance from the bottom of the vessel. This is a well-known result, right? Okay, let's go to the next question. The bomb is dropped by fighter plane flying horizontally. To an observer sitting in the plane, the trajectory of the bomb is. So now this is a question on relative velocity. It's like this. This horizontal projectile from a particular height. Now this is released. U. So is going to take a parabolic path to the ground. Whereas for the man who is now sitting inside the plane itself, how does the path is looking? Now that means any time, now the velocity of the horizontal velocity of the falling bomb is given by, relative velocity is given by, horizontal velocity is u minus, then from the reference frame also is moving horizontally with u. Therefore, this must be equal to 0. That means horizontal velocity, relative velocity v of the bomb with reference to the man who is sitting inside the aircraft. This is horizontal component. Okay, this is v x, let us call it as v of x, bomb of with reference to the man inside, to observer sitting. This must be equal to u minus u equal to 0. Then the vertical acceleration is g down. Therefore, this becomes a vertical down is the line of fall. That means the trajectory of the bomb is going to be a vertical down straight line. Understood? Must be answer straight line, vertically down. Let's go to the next question. The trajectory of a projectile near the surface of Earth is given as y equal to 2x minus 9x squared. If it were launched at an angle theta and with speed v0, then what is it? Now This now the equation of the trajectory of the ground to ground projectile. We just compare with the equation which we know. This is equal to x tan theta. What is the formula? X tan theta minus half g x squared by u squared cos squared theta is a formula. Now here it is. Therefore, looking at this is given as 2x minus 9x squared. Therefore, now in this case tan theta equal to 2. Okay, compare it with this standard formula. You get tan theta equal to 2. That means cos theta is equal to cos theta is 1 by root 5. Therefore, cos squared theta is 1 by 5. Right? Therefore, now here is and then take g equal to 10. Therefore, now half g is 5. 5 gets cancelled. Therefore, x squared. Therefore, y equal to. Therefore, now it becomes x squared. This is 9. Use b squared. Half 5 gets cancelled. Therefore, u squared. 9 by u squared equal to 1. Or rather, g gets cancelled. Then 1 by u squared equal to therefore tan theta equal to 2, tan theta equal to 2, and then the 9 actually represents half g u squared cos squared theta equal to 9. Therefore, now substitute here. Therefore, u squared is what we want. U squared becomes equal to half g cos squared theta into 9. Half into 10 into cos squared theta is from this is 1 by 5. Because tan theta equal to 2 means cos theta equal to 1 by root 5. Okay. Therefore, this becomes 1 by 5 means 25 by 9 is u squared. U becomes 5 by 3. Therefore, u equal to 5 by 3, and then cos theta is 1 by root 5. U equal to 5 by 3, and then cos theta is 1 by root 5. This actually is a wrong printing mistake. It should be cos theta here. Okay. 1 by root 5. Next question. A shell is fired from a fixed artillery gun and with the initial speed u such that it hits the target on the ground with a distance r from it. If t1, t2 are the values of the time taken by it to hit the target in two possible ways, the product is. Now, this is now the same range. There are now two theta. That means this is now typical. One is like this, other one is like this. This takes now time t1. This takes time t1 for the time of flight. This takes now t2. Now they are asking what is the value of t1, t2 product. Therefore, we know this is now t1 equal to 2u sin theta by g. This becomes 2u cos theta by g. Therefore, the product t1 and t1, t2 becomes 4u squared sin theta cos theta by g squared, which can be written as u squared into 2 sin theta cos theta becomes sin 2 theta multiplied by 2 divided by g, another g. This must there equal to r. This is now the range formula into 2 by g. 2r by g is the answer. Option D. Understood? Okay, let's go to the next question. Two particles are projected from the same point with the same speed such that they have the same range r. Different maximum height h1 and h2. Which of the following is correct? we know obviously from the well-known formula H1 is proportional to tan theta, H2 proportional to cot theta. Therefore, this is H1 is R by 4 tan theta, H2 is R by 4 cot theta. Therefore, the product H1 and H2. Therefore, R squared equal to 16 H1 H2, R equal to 4 root H1 H2. Which one is correct? Therefore, R square 16 is correct. Next question. The initial speed of a bullet fired from a rifle is 630 meters per second. The rifle is fired at the center of the target 700 meters away from the same level as the target. That means this horizontal range is 700 and the initial speed is 630. How far above the center of the target? That means this now a typical question like this. This must be aimed at what distance? This is very similar to what we have solved a little bit earlier. What is this height h? This angle is theta. How far above the target? Initial speed of the bullet is 630. At the center of the target. How far above the target it will hit? Above the target it should be aimed at. Okay. So that is now very typical of what we have already solved. R equal to 700 is given. U is equal to 630 given. If we know theta, we have to find it out. And once we find out the theta, then we follow the h is equal to 700 times tan theta. Why? Because from the triangle h is opposite side. This is now adjacent side. 700 times tan theta. Once we find it out, this. Therefore, now this is now very typical of what we have already solved earlier. And I suppose if you want to actually solve it right now, we just do that. Now you take this R formula as 700 equal to U squared 630 squared sine 2 theta by 10. Okay, from here now you find that sine 2 theta is very small value, they are equal to 2 theta. So this problem is very similar to what we had done slightly earlier. So now I have now shown you the solution here in detail. Just go through it. Final answer comes to 6.1 meter. Let me also explain briefly how the solution is arrived at. Because now R is given as 700, U is given as 630, theta is how much, and then find out the theta and then put it into this particular formula, because what is asked for is how much higher than the target one should aim. Or rather, in order to hit the target, then how much, supposing now you are aiming at the elevation angle theta and then firing, then how much height over the target you will be hitting. So therefore now that is a question which is asked. H is given by now this side 700 times the tan theta. Okay, therefore we have to find out this. First of all, therefore we should find out what is theta. Now like this. Therefore now we just use a formula for range equal to U square sine 2 theta by G. Range is now 700. U is 630. Put it. Then sine 2 theta unknown. Then G is 10. Therefore from here you can find sine theta equal to 700 into 10, 7000 divided by 630 squared. Now this you can find is a very very small value. Therefore you can equate it sine 2 theta equal to 2 theta. Therefore now 2 theta. Therefore now this is equal to 2 theta. Therefore you can find now theta is just divided by 2. Right? This is what is there. Then and therefore now having found out the theta, we have to find this also is equal to tan theta, because theta is very small. Therefore you find out h is equal to 700 tan theta, 700 times this particular value. When you do it, you get 6.1 meter, which is option C. Understood? Okay, next we go to the next question. Yeah, read this question. The position of a projectile launched from the origin at t equal to 0 is given by r vector. Position vector is given by 40 I cap plus 50 j cap meters at t equal to 2 seconds. If the projectile was launched at an angle theta from the horizontal, then what is theta we have to find out. Therefore, now this is now position vector means at t equal to 2. Therefore, we can write the x and y from the fundamental equation, which is nothing but we can write x equal to u cos theta t, we know, and then y equal to u sin theta t minus half g t squared. Okay, this is the fundamental basic formulas. Okay, therefore now here it is given now t equal to 2 seconds. Therefore this is now 2, and therefore this is now 2, and then half g t squared becomes 5 into 4 equal to 20 minus 20. Now at this time x is given as 40 and then y is given as 50. Therefore you 2 2. Therefore now this becomes 70 this side. If you cancel this to the other side, then now you divide, then you get, or rather divide other way. 70 by 40 gives you tan theta. Check that. 70 by 40, 7 by 4. Right? Understood how we have done? Let me just repeat. X is equal to u cos theta t, y equal to u sin theta t minus half g t squared. Therefore, t is given as 2, substitute it here. And then x value is given as 40 and y value is given as 50. Substitute it, therefore you get u cos theta into t and the u sin theta into t. How much? Therefore you are getting u cos theta into t into 2 as 40, u sin theta into 2 as 70. Divide one by the other, you get tan theta equal to 7 by 4. Okay, let's go to the next one. Let's go to the next question, which is a ball is projected from the ground at an angle 45 degree, just clears a wall in front. If the point of projection is 4 meters from the foot of the wall and the ball strikes the ground at a distance of 6 meters on the other side of the wall, then the height of the wall is. Let me just draw the figure. It's like this. This is the ground. A ball is projected at an angle 45 degrees. This goes like this and falls. There is a wall in front at a distance of x equal to 4 meters, and then it just clears a wall, it just grazes the top of the wall and then falls on the other side at 6 meters. Okay, now they are asking what is the height of the wall is. Height is how much? Now what is now the range is 4 plus 6 is equal to 10 meters. Now we already know the well-known concept. When you extend this 45 degree line like this and then continue this particular ordinate, this is called as y, this is called as x, and then and therefore now y we know is equal to tan, our symbol is alpha times x tan alpha, whereas this is total height is equal to x tan theta, where now this is now tan theta is x is equal to 4, therefore and then tan theta tan 45, therefore this is equal to 4, we know, and then we know the well-known result, which is y divided by this 4 full height. Let me just now show this. This is what we know is this divided by this equal to r minus x divided by r. Therefore, we can write it as now y is what we want, that is h is what we want, h divided by 4 tan 1 equal to 4 equal to 6 divided by 10. Therefore, h is equal to 2.4 meters. Understood? 2.4 meters. Fine. Let's go to the next question, which is a ball is projected from the ground at an angle 45 degree, just clears a wall in front. If the point of projection is 4 meters from the foot of the wall and the ball strikes the ground at a distance of 6 meters on the other side of the wall, then the height of the wall is. Let me just draw the figure. It's like this. This is the ground. A ball is projected at an angle 45 degrees. This goes like this and falls. There is a wall in front at a distance of x equal to 4 meters, and then it just clears a wall, it just grazes the top of the wall and then falls on the other side at 6 meters. Okay, now they are asking what is the height of the wall is. Height is how much? Now, what is now the range is 4 plus 6 is equal to 10 meters. Now, we already know of the well-known concept. When you extend this 45 degree line like this and then continue this particular ordinate, this is called as y, this is called as x, and then and therefore now y we know is equal to tan, our symbol is alpha times x tan alpha, whereas this is total height is equal to x tan theta, where now this is now tan theta is x is equal to 4, therefore and then tan theta tan 45, therefore this is equal to 4, we know, and then we know the well-known result, which is y divided by this 4 full height. Let me just now show this. This is what we know is this divided by this equal to r minus x divided by r. Therefore, we can write it as now y is what we want, that is h is what we want, h divided by 4 tan 1 equal to 4 equal to 6 divided by 10. Therefore, h is equal to 2.4 meters. Understood? 2.4 meters. Fine. Go to the next problem. A plane is inclined at an angle. This, by the way, this inclined plane problems are only for JEE Main only. NEET students can ignore these problems. A plane is inclined at an angle alpha equal to 30 degree with respect to the horizontal. A particle is projected with a speed of u equal to 2 meters per second from the base of the plane as shown in the figure. The distance from the base at which the particle hits the plane is close to. Take g equal to 10 meters per second squared. Now, this is asking for the range on the inclined plane. Then our symbol in our formula is r dash. R dash we know is given by what is the formula which you have got is u squared 2 sine theta minus alpha. Theta is the angle of projection with reference to horizontal. Alpha is the angle of the inclined plane times cos theta divided by g cos squared alpha is our formula. Now here let us just put what is the value which are given. U equal to 2 is given. Then Then theta minus alpha, we have to take it as 15 degrees, because in this particular figure they are given the theta as only this, whereas in our formula it is now theta is the whole theta, which is 30 plus 15, 45 degree, alpha is 30 degree. Therefore we must take theta minus alpha as 15 degree, and of course now theta has 45 degrees, and then alpha of course is 30 degrees. If we're using this, we can calculate R dash. Okay, let's go to the next problem. This also is JEE Main only. Yeah, now let us see. Your body is projected at t equal to 0 with a velocity 10 meter per second. That is u equal to 10 at an angle of theta equal to 60 degrees. The radius of curvature asked for is radius of curvature at t equal to 1. T equal to 1, the radius of curvature is capital R. We will use the symbol small r for radius of curvature because we should not confuse with the range R. Therefore call it as R. Now at t equal to 1, then, and of course now g equal to 10. Therefore then what is the formula, if you can recall? By the way, this also is only for JEE Main only. Now radius of curvature formula is velocity cube divided by g into u cos theta. Okay, now u is known, theta is known, g is known, therefore denominator is known. Now what is at t equal to 1, what is the velocity, we have to find it out. Therefore at t equal to 1, then x component of velocity, which is now same as u cos theta, which is nothing but 10 into cos theta 5. And then y component of velocity is given by u sin theta minus gt. At t equal to 1, gt is minus 10. Therefore this becomes u sin theta is 10 into sin 60 is root 3 by 2. There 5 root 3 minus, obviously now it is negative, mean the projectile is coming down, that's descending stage. Therefore this we must take it as, this is downwards velocity given, this is equal to 10 minus 5 root 3, and then the horizontal velocity is 5. Therefore now this v we can find out from here as v equal to square root of 10 minus 5 root 3 whole squared plus 5 squared. Okay, once you find out v, you have to find v cube as a numerator. Already we know denominator, therefore we can calculate the r. Therefore you can do the mathematics and then try to check the answer. As I said, that if you know the formula and if you know the method, then save your time on the calculation, which you can always do in the actual exam. You can do it correctly. Therefore there is no point wasting time just on the calculation part of it. You simply go through the method, and then if you are confident about the method, and the calculation will come to you automatically. No need to waste the time doing a lot of mathematics unnecessarily. Okay, let's go to the next question then. Question number 27. Particle moves in a plane with constant acceleration in a direction different from the initial velocity. Then the path of the projectile is. Now this is very similar to a projectile. What happens? You have a u at an angle theta with the horizontal, whereas now the constant acceleration g is vertical downward. That means the initial velocity is oblique to the constant acceleration direction. Therefore we already know then the path of the projectile is a parabola. Therefore very similar here also is, now the initial velocity direction is different from the constant acceleration direction. Therefore this got to produce a parabolic path curve. Therefore you can tick parabola, option number B. Next question, we go to two particles A and B are connected by a rigid rod AB. The rod slides along a perpendicular rails as shown figure. the velocity of A to the left is 10 meters per second. Then what is the velocity of B when it is angle is 60 degrees? Now, such kind of a question, we are not actually taught. I have not actually taught you how to solve such kind of a question. But now I'll take the opportunity now to teach you. Now all this kind of a question about the velocity of one end of a rod is given, and then the velocity of other end is taken. Then you have to go with the geometry relation and then do like this. What we need to do it is, let us take like this. This is now the triangle. Okay. Now this now the rod. This now the wall. This now horizontal ground. Therefore now let us now call, now the length of the rod is going to be constant. Therefore we take it as now length is given by square root of, let us call this as this distance as x, this height as y. Why? Because we consider this as the x-axis, consider this as y-axis, this is origin, in which case then this is now x, this is now y. Therefore then what is the length of the rod is going to be given at this particular time is going to be given by L equal to root of x squared plus y squared, or you can write it as L squared is x squared plus y squared. Fine. Next, then what happens is, now because L is constant, we can say that x squared plus y squared equal to constant. Therefore differentiate it, you get 2 into dx with reference to time. If you just take it as 2 into dx by dt plus 2 into dy by dt equal to 0 is what you get. Then 2 gets cancelled anyway. Now what is meant by dx by dt? No, I'm sorry. We have to have 2 into x here and then 2 into y. Let me just rewrite it here. This becomes 2x dx by dt plus 2y dy by dt equal to 0. Then the 2 gets cancelled. Therefore now what is now dx by dt is velocity of x plus what is y, dy by dt is velocity y component equal to 0. Now from here, what is this? This actually gives you velocity of y is equal to velocity of x times x by y. Okay. Now what is now given is velocity of the x, in this case that is velocity of the point A is given by how much? 10, that is towards negative, that is decreasing x, that means you have put as minus 10. Okay, towards negative x direction, minus 10 into what is now x by y, this angle is given as 60 degrees. Therefore x by y is cot 60, or which is equal to x by y is given by 1 by root 3. Okay, therefore Vy is minus 10 by root 3. 10 by root 3 is approximately less than 4. Okay, check it up. Vy, yeah, this is 10. And then what is x by y? 60 degree root 3. 1 by root 3. Into 10 by root 3, which is equal to, therefore this must be equal to 10 by root 3 is modulus value, which must be equal to 5.8. Okay, let's go to the next question. The x and y coordinates of the particle at any time are x equal to 5t minus 2t squared and y equal to 10t. Now this you can make out from here. that x direction has got a constant acceleration. Why? Because it is in the form of displacement equal to ut plus half at squared form. Similarly, y direction, it got a constant velocity, you can easily make out. Why? Because it is in the form of vt. Therefore, it's like this. Therefore, x and y are in meters, and the t is second. Then the acceleration of the particle at t equal to 2 seconds. Obviously, now because it is a constant acceleration along x and then zero acceleration along y, the answer is constant acceleration along x direction, which is what equal to half a t squared is minus 2. Therefore, a must be equal to minus 4. Understand? Therefore, simply looking at it, you can actually equate it. Therefore, whenever you come across a displacement relation is in the form of at square plus bt plus c, that means quadratic in t, then it is a constant acceleration along the direction. Similarly, now if the displacement relation is a function of linear relation with time t, then it is a uniform velocity case. As you can see in this case, now you have now displacement x is a quadratic in t, therefore there must be acceleration is constant along x direction, and then the displacement y is with a linear function of time, therefore it should be a constant velocity and therefore zero acceleration case. Right. The next one you can go through. A body of 3 kg moves in the xy plane under the action of a force given by 6t squared plus 4t. If it is a force, then force divided by mass should give you the acceleration. Therefore, you can straight away now look at it and then write the acceleration relation as divided by the mass 3, you get 2t squared I cap plus 4 by 3 t j cap is the acceleration. Acceleration is therefore now is a function of time. Okay, therefore it is varying with time, therefore it's not a constant acceleration. Then assuming that the body is at rest at time t equal to 0, at t equal to 0, velocity equal to 0. Then the velocity of the body at t equal to 3 seconds, we have to find the relation velocity as a function of time first. Then you can put the data at t equal to 3 and find out what is the velocity. How to find the acceleration is there, therefore velocity as a function of time is given by integral of a dt. Therefore now in this case it is now a vector thing, therefore integral of a dt. How we do it? Integral of 2t squared dt in I cap plus how much? 4 by 3 t dt in the j cap. Integration from time t equal to 0 till t equal to what we want? We want at t equal to 3. This is the velocity now. Velocity at time t equal to 0, it is 0. Therefore, we must actually now do like this. This is the actual velocity which is given. Therefore, this comes to now 2t cube by 3 I cap plus 4 by 3 t squared by 2. 2 by 3 t squared. This is j cap. This is from 0 to 3. You must put it. Therefore, this becomes 3, 9, 18 I cap plus this is 9 goes 3, 6 j cap. This is the velocity at t, because this is now 0 and then v, because initial velocity is given 0. Therefore, the answer is 18 I cap plus 6 j cap. Answer B. Right? Fine. We go to the next question. Motion of a particle in the xy plane is described by the set of all these questions belong to generalized to 2D motion on xy plane. Motion of a particle in the xy plane is described by the set of following equations. X is equal to 4 into is a sine function, y equal to 4 into is also is a sine function. Only thing is there is a phase difference between the x and y. Therefore, the path of the particle will be equal to, now, pi by 2 minus sine of 90 minus omega t is equal to cos function. Therefore, this becomes x is equal to cos omega t. This is gives x is equal to 4 cos omega t. Y is given as 4 sin omega t. Therefore, now you can simply say it is a circle y because this now cos omega t becomes x by 4 sin omega. Therefore, now square and add, you get x squared plus y squared equal to 4 squared. Why? Because cos squared plus sin squared becomes 1. Therefore, square and add, you get x squared y squared equal to 4 squared, which is nothing but, therefore 4 is the radius of the circle. Right circle. Next question. Starting from the origin at time t equal to 0, the initial velocity 5 j cap. Therefore, read the next question. Starting from origin at t equal to 0, initial velocity 5 j cap meters per second. Particle moves in the xy plane with a constant acceleration 10 I cap plus 4 j cap. At time t, its coordinates are 20 meter, y naught meter. That means now we have to follow this because constant acceleration, we can use the formula vector notation s equal to ut plus half a t squared. Now let's fill up this. This is now s is given by 20 I cap plus unknown y naught j cap is given by what is u is equal to 0 I cap plus 5 j cap times t. At time t, its coordinates are into t plus half into what is a vector. This also is a vector. A vector is given by 10 I cap plus 4 j cap into t squared. Now this is what is given. Therefore, now we relate I cap terms and then j cap term equated. Therefore, we now say that 20 is equal to, left hand side 20 I cap is equal to 0 times t, therefore 5 t squared. Then from here we know that t is equal to 2. Next we go to, therefore y naught equal to 5t plus 2t squared. So there is nothing but 5 into 2, 10 plus 2t squared is 2 into 4 equal to 8 equal to 18. Therefore, the answer is t equal to 2 seconds, y naught equal to 18. 2 and 18 is option number A. Understood how we have done it? Right, because it is a constant acceleration vector, we can use the formulas which we had, that is kinematic equation number 2 for the one-dimensional motion, we can happily use. Why? Because it is given, this is a vector notation, s equal to ut plus half a t square can also be taken as vector formula. Provided acceleration is constant only, you can use it. If it is not constant and if it is a variable with time, then we have to do differentiation integration business. Understood? Next question. The position vector of a particle changes with time according to the relation. Position vector relation is given in terms of I cap j cap and then as a function of time. What is the magnitude of acceleration at t equal to 1? Therefore, now differentiate it twice, then you get, because differentiate once you get velocity. velocity as a function of time vector is given by 30. The 15 t squared I cap differentiate with reference to time. You get 30 t I cap plus differentiate with reference to 4 becomes nothing. Then minus 20 is minus 40 t. This comes to minus 40 t. J cap is a velocity. Then acceleration, you differentiate it once more, you get 30 I cap minus 40 j cap. If acceleration is a constant acceleration, modulus of acceleration is equal to square root of 30 square plus 40 square will give you 50. Answer is 50. Next question we go through. A particle moves from the point Okay, just read the next question. A particle moves from the point 2, 4 at time t equals 0 with the initial velocity of 5 I cap plus 4 j cap, acted upon by a constant force which produces a constant acceleration 4 I cap plus 4 j cap. What is the distance of the particle from the origin at time t equal to 2 seconds? That means now you have to find out that r vector. Because constant acceleration, you can write r vector is given by, what do? ut plus half a t squared form, right? Because it's a constant acceleration. Therefore, we can write this as r vector. Of course, this initial thing is now 2, therefore we have to add up this any case now. Now let's now do this. This is what is u at t equal to 2 seconds. Therefore, we can straight away write as 5 into 2, 10 I cap. Or rather, what we have to do, which is 5 I cap plus 4 j cap into ut into 2 plus half into what is a 4 I cap plus 4 j cap into t squared, which is equal to 4. Now for this we have to add also initial position, which is not 0, 0, it is 2 I cap plus 4 j cap. Therefore do this exercise, you will get 10, this is 2 into 4, 8, 18 plus 2, you will get 20 I cap you will get. Then plus, then this is 4 is 8 and this also is another 8 plus 8 is 16 plus 4 is 20 j cap. Therefore now this is r vector. They are asking about distance, mean they want the modulus value of this is 20 root 2 is the answer. Understood? Okay, let's go to the next one. The particle with the initial velocity of 3 I cap plus 4 j cap, acceleration also is constant 0.4 I cap plus 0.3 j cap. Its speed. Therefore now it is u plus at formula in terms of vector. Therefore u plus at is 4 plus 3. Therefore this becomes 7 I cap plus 7 j cap. 7 root 2 units. Understood? Straight. Next question. The coordinates of a moving particle at any time t are given by x is alpha t cube, y equals beta t cube. The speed of the particle at time t is given. Therefore dx by dt is 3 alpha t squared plus 3 beta t squared. Therefore now the speed means then the modulus value of this is 3 alpha. 3t squared is common outside for alpha plus beta, alpha square plus beta square. Understood? Right. Therefore now that completes you had a good exhaustive worked out examples. We have done the workout and you must also have tried out the workout. Then as I told you that this we are given a PDF, exhaustive PDF of all the past questions both from NEET as well as JEE Main, and then topic wise also we are given what is the what are the questions to be practiced. Let me just now show you that particular page. Yeah, so then this page gives you the what are the question numbers which you have to practice from the PDF file which is there with you, and then do the practice and then enjoy. Thank you very much.